So in this problem, we're asked to determine what temperature is the dissolution of calcium hydroxide spontaneous. And so in order to think about this, we have to remember our criteria for spontaneity, our delta G expression, delta G equals delta H minus T delta S. And then we also have to remember that in order for something to be spontaneous, we need delta G to be less than 0 or negative. Now, in our previous problem, you may recall, and if not, you can go back and watch, we actually calculated what is delta H for this reaction and what is delta S for this reaction. So here, I'll just record these numbers. We found delta H to be negative 16.72 kilojoules per mole, and we found that delta S was negative 157.99 kilojoules per mole. And then we found at 298 Kelvin, delta G was a positive 30.4 kilojoules per mole. So we said at 298, this reaction is non-spontaneous. And so in our current problem, we want to figure out at what temperatures does this process become spontaneous, right? And we can think about that, and we can go back to our delta S and our delta H values that we see here. We see the delta S value is a very negative number, which is very unfavorable. But our enthalpy is also a negative number, which is favorable. So we can remind ourselves that this is a favorable value, but our entropy is unfavorable. What that tells us is that our reaction can be spontaneous if the delta H term is greater than the T delta S term, right? Anytime when delta H is going to be bigger than that T delta S, we are going to have a favorable reaction. So we can write that out if we want. So when delta H is greater than this T delta S term, absolute value, then it will be a spontaneous reaction. So how we can calculate that then is say, okay, well, let's solve for that. And to do that, we're going to say, let's say delta G equals 0. So let's take the case when delta G is equal to 0, right? Because at this point, we'll have reached the threshold where it's going to change from spontaneous to non-spontaneous. So if that's true, then our equation is still going to equal delta H minus T delta S. But now we can rearrange our equation by moving things to the one side or another, and we can say delta H is equal to T delta S. And then we want to solve for T now. And the way we're going to do that is divide both sides by delta S. And we're going to have T is equal to delta H over delta S. And now we can go ahead and substitute in our values above, paying attention to our units. So our delta H, I'm going to write is 16,720 negative joules per mole. I converted that to joules. We're going to divide that by negative 157.99 joules per mole per Kelvin. And if we divide that out, we find out our temperature ends up being 105 Kelvin. So what does that tell us? Well, that tells us that our reaction is spontaneous when it's below 105 Kelvin, right? Because, and the reason for that is we're looking at this expression right here, right? We said this reaction will be spontaneous when the delta H is greater than the T delta S. And the reason for that is that'll make our delta G negative, because delta H is a negative number. So as long as the temperature is below this 105 Kelvin, our reaction will in fact be spontaneous. So the only time the dissolving of calcium hydroxide is going to happen is at very, very cold temperatures.